Hi, and welcome to Week 5, Valuation of Non-Market Goods. Can we defy nature's end? Is saving remaining biodiversity still possible? Is protecting biodiversity economically possible? All of these are yeses according to recent research. Total protection using a global reserve network would cost about $30 billion per continent. These add up to less than 1/2000th of the cost of ecosystem services that nature provides for free. Paradoxically, researchers know what we have to do, but governments and global organizations have not synthesized that into collective action. Behold, a majestic landscape of Arthur's Seat. This is a protected green space in central Edinburgh. Services provided by areas like these green spaces contribute to human welfare both directly and indirectly, and they represent part of the total economic value of the planet. And, by the way, the total economic value of the planet has been estimated to be an average of $33 trillion per year, most of which is outside the market, meaning private costs and social costs. So most of that is externalities not accounted for in the market. And that is a conservative estimate. Our total global gross national product between all the goods and products and services is 18 trillion a year. So if you wanted to replace natural services, ecosystem services, you would need to come up with another $33 trillion a year. And that ignores the fact that many of nature's services are seemingly irreplaceable. So what is the value of Arthur's Seat? If we wanted to find that out, we'd have to think of all the services and functions it provides for free. So a list of ecosystem services might be gas regulation in the form of CO2 and oxygen, sulfur dioxide, nitrous oxide levels. It could include climate regulation at both international and local levels, storm protection, flood control, thanks to its vegetation structure. It could have water regulation, which could be used for irrigation or industry, water supplies for reservoirs or aquifers, erosion control, preventing runoff of soil by wind or rains, the storage of silt in its lakes and surrounding wetlands, soil formation by weathering of rock and the buildup of organic matter. It provides nutrient cycling, waste treatment, pollution control, detoxification. Also, key habitat for pollinators, a refuge for migratory species. There's toad migrations where they close the roads around Arthur's Seats for part of the year. There's also flood protection, a source of raw materials, genetic resources. Did you know 9 of our top 10 pharmaceutical drugs are derived from nature? Also, probably most importantly, it provides recreation, outdoor recreation activities, and also cultural value like aesthetic, artistic, educational, spiritual, and scientific values. Have a look at this short video explaining briefly in a visual and audio way the huge, vast array of nature services. Cost-benefit analysis is an analytical tool that policymakers or decision makers might use. CBA in its simplest form would weigh up the benefits defined as increases in human well-being or increases in human welfare, and costs defined as reductions in human well-being using monetary forms. Some way, the principle can be guided by the framework that some way has to be found to aggregate environmental and social benefits across different people within a given geographical boundary. and then finding some means of monetizing those. You could use CBA for determining whether to build a coal or wind power plant, constructing a shopping center in a rural area versus allowing that area to stay intact, or constructing a shrimp farm versus leaving a swampy mangrove area in place. So the most important component is base situation. What would happen if no changes were made? If it happens to be that no changes result in more monetary value for the people in that geographical area, then the project will not occur. The most controversial aspect is discounting, which brings up themes of intergenerational equity. Now, the valuation of discounting involves a mathematical formula to determine the present value of future benefits and costs. For example, because of inflation, a pound today will not be worth the same amount in 50 years. And today's pound could be put to other uses, which decreases its net future value. The criticism is that the CBA discounting approach poses problems for intergeneration equity because it downweights the cost to future generations, the loss of biodiversity, for example, and climate change. The big challenge of CBA is also that the costs and benefits are not easily transferred into monetary values. We're often dealing with things that are not traditionally monetized, like cultural values or aesthetic values. CBA might look to infer willingness to pay or willingness to accept for things that are not directly traded in markets. And finally, calculating the rate of return if the net benefits are found to be positive, you would use a sensitivity analysis. You would replace the unknown parameters with alternative values like predictions from global climate models and state whether your cost-benefit analysis qualitative results are sensitive to those parameters. So let's start with private costs and benefits. Identifying private costs and benefits are relatively easy to identify, as these are captured in market transactions using monetary means. So let's think about the effects of building a bridge over a river. Private costs would equal the construction costs, the operating costs, and the maintenance costs. And the private benefits would include the direct amount the consumers are prepared to pay, for example, the taxes to help build that that bridge over the river, or tolls that need to be paid for anyone going over that bridge. These are the things a firm will think about, but they'll often ignore the externalities. So a CBA has to think about the other effects that don't have a price. So when we look at the externalities in production and consumption, we would think about the negative and positive social costs or social benefits. So the social costs that wouldn't be included in a traditional kind of assessment of the prices and costs could include the excessive noise and construction, the loss of countryside, the depletion of local flora and fauna, and reduction in biodiversity, and the inconvenience of having to maybe drive through another area or be exposed to particles of dust in the air. But the social benefits could be time savings for travelers as overall congestion decreases and there's less and less traffic flow going through alternative routes. Fewer accidents. There could be, no more huge pileups on a bridge that prevents everyone from getting to their jobs on time, and that increases the economic output of of the of the city or region or geographical area. And of course, saving money. There could be a lot of money saved by having this new bridge. Okay, so how do we value externalities? So let's take noise or loss of countryside as a negative externality. What value do people place on these? By how much do those who suffer need to be compensated? You could ask them using a questionnaire. Here we would try to figure out their willingness to pay or their willingness to accept using contingent evaluation surveys. For example, if 50,000 affected people value the loss of a countryside at £5, then we would take 50,000 times 5 and we could estimate the cost to be £250,000. And for time savings, we could ask, okay, so what value do we place on work time saved or leisure time saved? That could be our research question. And is the time saved worth the same to everyone? If 100,000 hours are saved and valued at £4 per hour, then the benefit would be £400,000. And if we wanted to reduce accidents, we could find maybe through some market research or via questionnaire, we could find that every accident prevented would be savings of £750,000. So if the bridge stops one accident from happening per year, the annual benefit is £750,000. But then we would think about the likelihood of a benefit. Let's say there's a 50% chance that an accident that stops traffic flow occurs every year. Then the benefit is 750,000 times 0.5, which would be 375,000. And in terms of does time make a difference? The major costs of the project happen straight away. The benefits, however, occur over the life of the project. So the bridge may cost $5 million to build, but consumers benefit by $1 million a year. If the expected life of the bridge is 25 years, then economists would discount the value of the 1 million benefit in 25. They use discounting to value the 1 million benefit in 25 years' time. And commonly, the rate of interest or inflation is used to discount the future earnings, as the 1 million in 25 years will be worth substantially less today. Because remember, money loses value because of inflation. So over time, the value of the benefits will fall as inflation erodes the value of the pound. So then you decide with all that, finally, is the project worth undertaking? And it's only worth undertaking if the discounted benefits outweigh the discounted costs. And so to find out environmental and resource values, some non-market valuation techniques look to observed behavior in related markets. For example, the travel cost method is used to estimate the benefits of national parks and recreational fishing areas based on the expenditure that visitors make in traveling to such areas. Another technique, the hedonic price method, is able to investigate how environmental quality affects the price of other goods and services. Differences in housing prices, for example, can be used to isolate the value of things like a scenic view, local air quality, and proximity to hazardous waste. And other possibilities range from looking at insurance markets to value the costs of more extreme weather events, and looking at agricultural land prices to value differences in climate. Researchers can also look at adaptation to climate change as an averting expenditure to estimate particular costs of a changing climate, all of which then feeds into decision making and policy making at the government level. So, the most common way for economists to measure an individual's value for something is through the intuitive concept of one's willingness to pay. But there are many things that people value, such as environmental quality, for which they pay nothing, at least not directly. So, to account for these values, CBA often requires the use of non market valuation techniques, where the aim is to infer willingness to pay or sometimes willingness to accept for things that are not directly traded in markets and for which there are no immediate prices. So, surveys are the most common method of contingent valuation, but there are some problems with surveys. Questionnaires only capture a snippet in time. Response rates can be disappointing. You can get a much lower response rate than you might think is needed for a representation of the population. And people can be bad readers for various reasons. Physical limitations like visual impairment, dyslexia, etc. Questions have to be simple, they have to be unambiguous, and so they might not capture the complexity of the topic. And the questions, if they are closed questions, they have to include all the possible responses. Otherwise, people might feel like their true opinion is not being reflected. So, in a choice experiment survey involving eliciting values and opinions on willingness to pay for maybe cattle ranch owners, you would have an upfront filter question, which would say basically only proceed with a survey for those who desire some kind of exclusion for cattle. So if you answer option A, B, or C, then it would you would be able to proceed and answer the rest of the survey. And you might do that because you want people to give a meaningful willingness to pay. And clearly, the ones who are not interested in conservation would not value that, and maybe would um, create erroneous results or skewed results. So essentially, you have to consider whether respondents who don't have conservation requirements should be included, as again, they may not be responsible to the conservation effort and they might be unable to give a meaningful willingness to pay. Of course, you could deem it's very important for your study to include these people and maybe give results indicating their responses and one that does not indicate their responses. So there's not hard and fast rule for that kind of thing. Total economic value is another one of the most widely used and commonly accepted frameworks for classifying economic benefits from ecosystem services and for attempting to integrate them into decision making. There's a number of examples which I will direct you to gain a better understanding of this concept. But TEV basically takes into account subsistence and non-market values, ecological functions, and non-use values, which I'll speak to in more detail. So non-use values, bequest and existence value, have no trace in market behavior. You can see these to the far right of the schematic. They show up in the absence of any use of environmental or natural resource amenity, and they're based on the satisfaction of simply knowing the amenity exists in a particular state. Many people have, for example, a willingness to pay to ensure that Arthur Seat continues to exist, even though they may never plan to directly go and participate in exploring or visiting Arthur's Seat, at least not on a regular basis. The estimation of non-use values requires the use of hypothetical markets. So we have to make a choice experiment or an imaginary scenario in which contingent valuation then directly questions people through surveys about their economic value. You can see the previous choice experiment example, and I can link to some other willingness to pay surveys. These methods are widely used in both cost-benefit analysis and total economic value and natural resource damage assessments. But there's a lot of scrutiny and criticism surrounding the legitimacy of the values themselves. How are they determined? And the ability to reliably produce estimates, as maybe you could do two surveys at two different times and get completely different results. So examples of research articles describing the application of the choice experiment and the implications of the valuation results for policy are, are some readings this week, including mangroves versus shrimp farms and threatened birds in Australia. Of course, things are not always as cookie cutter and precise as what's accounted for in a theoretical choice experiment. All kinds of issues arise in practical situations in terms of paying for ecosystem services or PES schemes. Like development issues, livelihoods, equity for the poor, conservation effectiveness, uh, these are all kind of main themes circulating around various issues. For example, people with a lower income have a lower ability to pay and therefore have less influence in paying for ecosystem service schemes. They theoretically, you could use distributional weights, but those are rarely put into practice. And some related issues that we could branch off and discuss interrelating with the themes covered today are the global commons. Of course, the global commons are Earth's shared resources. So, how do those come into play when we're talking about the total economic value of all these? Who owns all these resources? In our current economic structure, property rights are resources owned by individuals, associations, collectives, or governments, and those all interplay with these global commons that we all benefit from. And those two are often in conflict and have to be found to interact with each other in a productive way. We can also think about the terms of futurity, futurity, whatever. It's the long-term viability of ecosystem services, systems that depend on the sustainable use of natural resources. So this really brings up the intergenerational equity. You know, what's happens to our generation if there's an irreversible tipping point, and how does that affect, the state of ecosystem services for not just us but future generations? That links basically into what I just said about irreversible decisions. Uh, we could make horrible decisions with discounted rates that don't reflect the value of the goods. They're tremendously undervalued, and then the monetary value of ecosystem services go like super high because we thought, oh, you know what, we've calculated the Earth's willingness to pay for the Arctic not to melt at X rate, but now it's all melted and sea levels have risen dramatically. We would love to have those ice sheets back, but now those ecosystem services, the price that we're willing to pay is at a near infinite value because we're all drowning in seawater, and technology can't replace it. So now it's extremely high. So we could crash our way of life beyond a point of repair. We could have limitations of money measure. That means many things are difficult or impossible to monetize. And there are people who will flatly not want to engage with the willingness to pay because they feel things are priceless, and that placing an economic value on them is effectively devaluing. Okay, so that is the end of this week. You've got a lot on your plate in terms of dealing with the essay. So the discussion board is just for general questions and any concerns, and I'll be hopping on there and answering everything. So I'll see you next week.